Hello to everyone. So today we are going to say about that is another one topic is called similarity measurement. So this is considered the important topic in data analytics. Similarity measurement means when we have to feed that is certain query, and then that query that has to be retrieved from the entire data set. If I am feeding that is any input text, that has to be processed. In that process we are having that several stages. It has to be formed as a query, and then we have to refer into the database, and then it has to be referred with an index, and then so sorting, and finally it has to show that is the text results. So this is the normal search process that is happening in that any kind of that mining. Even in case if we are taking into the Google search, we are feeding that is certain text, and then that query has been passed to the clouds of that Google, and then that has been searched, and that has been indexed, and finally sorted out. The sorted outcome which is having that highest priority, so which is closer relevant to that respective query, that has been ordered and then displayed in that browser. So this way the normal searching process is happening. In that data mining, we are talking about that is the similarity, so measurements. It has to be done between the two documents or two queries, or one document and one query. In every retrieval we have to rank that the outcome of the retrieved documents. The similarity measurement, it's a kind of that function, and we have to be compute in between the degree of the similarity in pair of text objects. In case if you are having the large number of similarity measures, especially in that literatures or that some other documents, we have to be apply that is the appropriate similarity measurement. The thing is, so still we can't able to derive the 100% accuracy based similarity so measurement algorithms, but somewhat we derive that is a certain good accuracy based similarity measurements algorithm. Before look over into the varieties of that algorithm represent for the similarity measurement, now we have to say how the result that has been measured in classical similarity measurements. In similarity measurements, the similarity range that has been defined from 0 to 1. If I am getting that is the similarity measurement value as 0, then we can able to come to the conclusion the queried text and then so retrieval text is not having that any kind of that matching, so that it produce the results of that 0. In case if I am getting the result of that 1, and then we can able to come to the conclusion the queried text or that document that having the 100% or that somewhat 80% or that 90% of the relevancy in case if it is produced as a retriever. So 0 shows that is a minimum similarity, or we may say that is incompatible similarity, and 1 shows it's having that's a maximum similarity. So this way we can able to classify that is the similarity measures. And then what are all the conversion that has been happened in the similarity measurement. What we say that is that earlier the one shows that is incompatible similarity in the range of the 1 to 10 scale. So this is purely depends upon the scales, how much of the relevance for the queried and then so retrieved data sets. If I am saying that is the 10, and then it returns the 100% of that relevancy for my query. So generally we are saying that is the S dash equal to S minus minimum of S, that's whole divided by maximum of S minus minimum of the S. So this is somewhat non-linear kind of that variety. And next one we have to say vector space model. This vector space model, it has to be provided by that Salton at the year of 1960, and it's applied that is the SMART. We say that is in SMART. So expansion of the SMART is a system for the mechanical analysis and retrieval of text. We have to be analyze the system of the text or that documents that has been stored, and it has to be retrieval of the text. So this is the concept of the SMART, the vector space model that has been implemented in the similarities on the measurement. In case if I am having that is the data set which is called that is the D, and it's having that M web documents, and then we can able to say the D is the set of that documents starts from that D1, D2 and DI up to that DM, and that web component of that I is varying from that 1 to M. So this way we can able to give that is a definition for the data sets, what we said that earlier. So in case if it is n words among that m web documents, we are searching that word document, searching a word in a web documents, and then the formula we have to say that is the di, the set is varying from the wi1 comma wi2 comma wi3 up to that, so win, and that I is varying from that 1 to up to m, and j is varying from 1, 2, 3 and up to that n. So in case if you are saying by that q, the q is varying from that set of q1 to q2 up to that qij and then qim. So the I is varying from that, so 1 to n. So the similarity, so the measurement of the technology, it's happening between the retrieved of that A and that's relevant of the B. So already we studied these concepts in the schooling itself. We are talking about that is that set theory. A is that retrieved, and then B is that relevant. If you are taking that is the common space, is generally we say there is the A intersection B. This is called retrieved and relevant. So normally in case we are calculating that is the precision, the formula stated that returned relevant documents, that's whole divided by total returned documents. Simply we have to say the precision of A comma B, that means the precision of retrieved comma relevant. Simply we have to say for that understandability. So P of A comma B equal to A intersection B, that's whole divided by mod of A. So mod of A intersection B divided by mod of A. So when we have to be applied, that is the recall, and then the returned relevant documents divided by total relevant documents. Again we have to be research, and then we have to be give that is the formula capital R of A comma B equal to A intersection B, that's whole divided by mod of that B. So this way we have to be apply the similarity measurement in between retrieved and then relevant. So now we have to say that is one more example. I am having that is the relevant A, C, E, G, H, I, J. So these are all that are relevant. And then so retrieved is W comma Y. And then what is the common space is retrieved is B, D, F. That is the retrieved and then so relevant. So we have to be say A intersection B, that is the mod of A intersection B equal to relevant intersection and so retrieved. So relevant we are having that is that A, B, C, D, E, F, G, H, I, J. We are having that is the 10 components is there. And then so retrieved, so we are having that B, D, F, W, Y. Since retrieved that is marked is in that red color, and then relevant that is marked in its blue color. So in that retrieved we are having that total components of B, D, F and W, Y. So when we intersect, that is we have to be go with that common space of that A intersection B, and then we are having that three components is called that is the B, D, F. So the precision that comes from on whole that is the 3 divided by mod of A. So here that mod of A we are having the total of 5 set elements. So 3 divided by 5 we have to say that is 60% of that accuracy in the relevant and retrieval component. In case if we are applying that is the recall, and then we are having that 3 divided by that is the 10. So 10 means we are having that mod of that B. So if it is 3 divided by 10 and we are getting that answer, that is the 30%. So in case if you are going with the recall, automatically the accuracy that has been reduced. So this is an example. So we have to be compute how the simple measure it's happening in that similarity measurement. And now, so this is the precision and recall graph curves From that curve itself we can able to understand in between recall and then some precision. Almost there seems to be the inversely proportional. If the precision is high, the recall is low. If the precision is low, the recall is high. So this way we have to be determine two hypothetical results. And now we have to say what are all that algorithms that has been used for similarity measurement, that is based on VSM, that is the vector space methods. So first one is called dice coefficient, and number 2 that is overlap coefficient, number 3 is Jacob, number 4 is the cosine, and number 5 is asymmetric, and number 6 is the dissimilarity, and finally we may say other measures. So all these algorithms we have to be discussed in the next part of this video. So thank you.